Hello everyone! This is the exercises video for the second episode in my Godot Shaders course. So these are the exercises. What I'm going to do is to go over each of them and explain what you have to do, and afterwards I would urge you to try to solve them yourself. And if you cannot succeed, or if you want to see if you solve them well, you should afterwards just check the solution. But until then, don't you dare check that solution, because I know you can do it. So let's get started and let's begin with the template that I have here prepared for you. I've created this template that has an instance uniform called CUV so that you can have two instances of your object just to be able to see how your UV changes in accordance to your sampled texture. Now for the first exercise, I want you to change the color of the sprite, which is the effect that many games have when something takes damage. Now, the key point you have to notice here is that when something takes damage, not the whole rectangle changes to that color, but just the shape of our object. So I would like the transparent pixels of my object here to stay transparent. So pause the video and try it yourself. Alright, so the first thing that I have to do is first of all to sample this texture. So to do that, you remember that I used to simply use a vec4 and call it, let's say, color, and make it equal to the texture that is sampled from this texture, following these UVs that we have defined here. Now that I have this color, I can set my final color to be equal to the color here. Okay, but up until now we just have the default behavior. We want to make it so that our object goes fully white or fully any color so that it looks like it just took damage. To do that, I'm going to create a uniform to pick that color. So I'm just going to make a uniform vec4 damage color, and I'm going to hint to the editor that this is a source color, so column source color, and simply set it by default to vec4 1.0, 1.0, 1.0, and 1.0. Okay, now what I can do is to assign this color to my color. So instead of assigning the color that I sampled, I could assign damage color, and you would see that everything turns white, and if I change this color, it turns to other colors as well. But the issue here is that I lost the transparency of the texture that I sampled. So what we have to do is to get a combination of our color and the sampled texture by simply writing a vec4 that has the color channel of our damage color and the transparency of our texture. So what I could do would be to simply write damage color.rgb, and as the final parameter I could use the color.a. And now, as you can see, I have the color that I selected here, and maybe I can make it white as the task required, but the corners are transparent, and this would work for any kind of sprite that has some transparency. So if you did this, well done. Alright, now for the second exercise, I want you to use this template and add some parameters so that we can modify the UVs in such a way so that we could zoom in to Godot's left eye. So you can pause the video to give it a shot. So if you remember, when we multiplied our UVs, we got that zoom in or zoom out effect, and when we added an offset to the UV, our image or our texture would simply move around. So let's combine those in order to zoom into the center and then to move the texture so that it focuses on the eye. Now for the zoom, I'm simply going to create a uniform float zoom, and I could hint towards the editor that the zoom is in a certain range, maybe if you don't want to get to negative values, but I feel like it's perfectly fine if we leave it to default value of 1.0 and don't tell anything to the editor. And I am going to also specify a displacement or an offset, but this time this offset can happen in all directions, so I'm going to make it, instead of a float, a vec2 and call it offset, because yeah, I can move horizontally or vertically. And again, the offset is going to be by default just 0.0 and 0.0. Now, with this in mind, I said that in order to zoom, we have to multiply our UV. So what I'm going to do is to take this UV and multiply it by zoom. Now, finally, after multiplying it, we can also add this offset to our final result. So plus offset in order to also move our texture. So let's see if it works. If I modify the zoom parameter, you see that this makes the Godot smaller, but if I take it down, you see that I zoom in. And now if I change the offset, I move to the left or to the right, and I could like do this, and now I'm kind of zoomed to Godot's eye. Alright, now for the third exercise, you might have noticed that when zooming in and out, the zooming happens from the top left corner. And this is happening because the top left corner has the coordinate 0, 0. So if we wanted to zoom from the center, we would have to do some operations on this UV so that its value, its center value, gets to be 0, 0. Think of some operations that you could do on this UV and see if you can make this scale from the center. Okay, now let's see what the solution to this is. To begin with, let's first just make this new vector 2 called centered UV, and let's maybe make it equal to UV at first, just so that we can replace our initial UV with the new centered UV that we are going to build. Now, our first thought to center the UV would be maybe to subtract 0.5 from the UV, because subtracting 0.5 would change the range of our UV to be between minus 0.5, 0.5 and plus 0.5, 0.5. So then, if I do this, the center is actually 0, 0. So let's see what happens. Well, first of all, you see that I'm not getting the whole texture. And why is that? Well, I'm not getting the whole texture because the texture is between the range 0 and 1. So if I wanted to have this interval that's between minus 0.505 and plus 0.505 to be between minus 1 and 1, I would have to multiply whatever value I got here with 2. Okay, and now I'm seeing the whole texture, everything looks fine, and if I zoom in, you see that the point from which I'm zooming is the central point. However, despite the point being the central one, my texture is still being offsetted. Okay, so why is this happening? Well, we did an operation to change the UV, and then we applied our effect here in order to zoom from the center. However, because we didn't change our UV back to still range between 0 and 1 as it did before, our texture, of course, it's not going to get mapped correctly. So after doing this operation, what we have to do is to change the UV so that it ranges again between 0 and 1. And to do that, we just have to apply the inverse operation that we did here. So for example, what I need to do is to simply write, okay, UV is now equal to what? Well, it's going to be the UV that I obtained here, but this time it's going to be, instead of multiplied by 2, it's going to be divided by 2. And afterwards, I have to not subtract 0.5, but I have to add back the 0.5 that I subtracted. And now if I save, you see that my UV is mapped correctly. But if I zoom, I am zooming from the center instead of zooming from the top left corner. Now, this exercise is very, very important because many times you want to do things from the center, and this is basically how you do it. Okay, now let's step back with the difficulty a little, and at the fourth exercise, what I want you to do is to flip the sprite on the X and the Y axis. So pause the video because we are getting into the solution. So first of all, we have to specify on which axis we want to flip. So in order to check if we flip on the horizontal axis, I'm simply going to make a boolean. So I'm just going to write uniform bool and flip age to flip horizontally and make it to false by default. And I'm going to copy and paste this to create a new uniform that's going to flip vertically, and again, it's going to be false by default. All right, so depending on which checkbox is selected, what we want to do is to flip the horizontal or the vertical axis of our UV. So what we can do is first of all to check if flip age is selected, then I'm simply going to flip the x-axis of my UV. So what I'm going to do is uv.x equals to 1 minus uv.x. Since uv.x was initially 0, if we do 1 minus 0, we are going to get 1. And since the other one was 1, if we do 1 minus 1, we are going to get 0. So our new interval is now reversed. Okay, and the same thing we can do in case we have flip v, but this time we are going to simply flip the vertical component. And now if I look at my checkboxes, well, if I flip horizontally, you're not going to see on the Godot texture because it's actually symmetric, but you're going to see it on the UV that it's getting flipped horizontally. However, if I flip vertically, you are definitely going to see that the Godot texture is flipping. Alright, now what I want from you is to create a mirror effect that basically mirrors one side of our sprite to the other side, either vertically or horizontally. Please pause the video because we are getting into the solution. Now you might have noticed that I've added a mirror age and a mirror v parameter here, and the way we're going to use those is very similar to flip age and flip v. The only difference is that when mirroring something, we only want to flip the second half of the object, not the first half. So what we're going to do is to apply the same checks that we did before. So for example, if mirror age, then we are going to simply set the uv.x to be equal to 1 point minus uv.x. All right. And if we do exactly the same thing for the vertical mirror, we are going to do uv.y equals to 1 minus uv.y. Okay, but up until this point, what we implemented is just the flip. We have to also check if by any chance our uv x coordinate or y coordinate is larger than 0.5. So what I'm going to do here is to simply write and uv.x is larger than 0.5. You could even use a parameter so that you have a flipping effect, not necessarily in the middle, but more towards the left or towards the right. But for now, 0.5 is perfectly fine. And if I apply the same condition here, but this time for the y coordinate, you will see now that if I use mirror age, the UV is mirrored only halfway horizontally. And again, this is symmetric, so yeah, you don't see the effect here. But if I mirror vertically, you see that this mirrored and this also mirrored because this is no longer symmetric and I get this weird Godot logo. Alright, now for the sixth exercise, what I want you to do is to create a simple wipe transition by simply discarding all pixels that are before a given progress value. Okay, as before, pause the video and let's get to the solution. So first of all, I have to define my progress value, and I'm simply going to write uniform and float progress. And this time I want the progress to be between 0% and 100%. So I'm going to actually hint to the editor that it's a range between 0.0 and 1.0. And I'm going to make the step be 0.01 just so that it's a much smoother transition. Okay, and what I want to do now is to simply check on the x coordinate if my x is smaller than that progress. And for example, if uv.x is smaller than progress, then what I'm going to do is to simply discard. And now, actually that was it. So if, for example, I'd like to now move the progress, you'll see that I have this transition which discards all the pixels, and yeah, it's just a simple wipe. Alright, now for the final exercise, what I want you to do is to crop the sprite so that only the center of the sprite is visible. You can use any number to crop it. What's important is that less of the sprite is visible than it is right now. So pause the video because we are getting into the solution. Okay, so from the previous exercise, you might have gotten the idea to simply use a value and compare the x and y coordinate to that value. And if you did, well, that's basically it. So what I can do is, for example, to say if uv.x is smaller than 0.25, why not? Then I want to discard whatever pixels I have. And I have already created a side that is cropped. Okay, I can do the same thing vertically. So if uv.y is smaller than 0.25, again, I cropped the top side. All right, and now if I do it the other way around, if uv.x is larger than 0.75 this time, I cropped on this other side. And again, if I put uv.y to be larger than 0.75, then we got a cropped image. So yeah, pretty easy exercise here as well. All right, now these are all the exercises for now. I'd honestly be very curious to see how many of these you got right without looking at the solution in the comments. I hope this helped, and thanks for watching. Thanks a lot to my supporters, and see you in the next one. Bye bye!